Hello and welcome to the webinar about artificial intelligence to proactively maintain reverse osmosis system and minimize downtime. We are going to present to you Hubgrade Performance Smart Membranes modules. So the webinar will be presented by Marie Gavario, Digital Product Owner, and I. My name is Iman Kcheri. I'm a Marketing and Digital Communication Lead at Veolia Water Technologies. So we will start this webinar with a short presentation of Veolia Water Technologies. Then we will take a look at Hubgrade's Smart Membrane module through a demo. And you will discover two different use cases located in Oman and in the United Kingdom. And finally, we will answer your question. So please feel free to answer your question at any moment on the chat. So first, Veolia Water Technologies is the technology experts of Veolia Group, and we create specialized processes and solutions for sustainable development. We design and deliver water plants and technologies for municipal and industrial clients. We also provide service like digital offer for water treatment plants and management needs. What is Hubgrade? Hubgrade is a Veolia set of digital solutions that have been designed to answer operators and managers' challenges. It's a digital platform relying on data, on advanced analytics, and most importantly, on Veolia water treatment expertise. Hubgrade provide you with a dedicated portal centralizing all processes and relevant information about your plant for informed decision making. Hubgrade aims at measuring and optimizing our clients' processes and operation. And also, Hubgrade creates a link between you and Veolia Water Technologies process experts, so they can support you and they can advise you in the operation of your facility. So I now give the floor to Marie to present you more in detail Smart Membranes, a module part of Hubgrade specialized on reverse osmosis.
Thank you, Iman, and hello, everyone. So first, I would like to start with a little bit of a context. So studies have shown that consequences of membrane fouling and aging up to 25% of OPEX cost increase on reverse osmosis plants. Membrane fouling and aging have a direct adverse impact on items like energy consumption or CIP frequency, and they affect the plant availability as it can induce more frequent plant shutdowns and membrane replacements. It is therefore essential for plant operators to correctly assess the real state of fouling of the system and anticipate on drifts and loss of performance. And this is why we decided to create smart membranes. So how those smart membranes can help operating teams? First of all, by visualizing in real time the real state of fouling of the membranes, operating teams are able to act in time to avoid unplanned shutdowns. Additionally, smart membranes' predictive features help operating teams to optimize their maintenance planning by recommending the best dates to perform CIPs and membrane replacements. And because performing maintenance at the right time is not enough, but it also needs to be done the right way, smart membranes also help operators to benchmark different maintenance strategies so that they can select the best one for their plant in order to prevent membrane damage and maximize assets lifetime. So what is smart membranes? Smart membranes is a decision tool that combines artificial intelligence with our expertise in reverse osmosis to provide operators with recommendations on how to optimize the maintenance of their assets and ensure system health and maximum uptime. So how does it work? As with any data-driven tool, everything starts with data. To function, three types of data. First of all, data about the plant configuration for the initial setup. Then historical and real-time operational data are used to train and run the machine learning algorithms, and those data are coming directly from the instruments already present on the plant. And also manual log data linked to maintenance events can be entered directly through the web-based user interface by the operator, and are used also by the machine learning algorithms. Then once this data is available, first of all, fouling indicators like differential pressure or salt passage are computed and made available in real time. Those indicators are then normalized. And one particularity of smart membranes is that this is done without the help of any suppliers or ASTM equations, but thanks to a proprietary machine learning algorithm. Correlations between fouling indicators and external influencing parameters like flow regimes or temperature are detected by the algorithm. This allows to reveal the real trend of those operational parameters and to detect membrane fouling. Benchmarking indicators linked to past maintenance events are computed and made available through the user interface for easy comparison and analysis of the maintenance strategy of the plant. And finally, prediction models are trained and run to provide recommendations to the operating team. So now you might ask yourself, how does those machine learning algorithm work? The first thing to know is that our machine learning algorithms have been developed by a team of data scientists and Veolia reverse osmosis experts, meaning that we really get the best of both worlds. Once the model has been developed, the process is fairly simple. The machine learning model is trained on the plant's historical data to detect and learn about patterns and trends on key operational parameters. Once the training is done, we go to the inference step, meaning that the model will predict the evolution of the key operational parameters that we also call fouling indicators. Those predictions are then checked against operator adjustable settings. So this means that even if the tool works with artificial intelligence, the operating team ultimately still stays in control of the maintenance strategy of the plant. Predictions are then made available through the web-based user interface and through email notifications that the operators can choose to subscribe to directly from the user profile. So let's now take a look at our first use case. Our smart membrane tool has been implemented at the Oman Shore desalination plant in 2020. The plant produces over 130,000 cubic meters of drinking water per day from direct seawater intake and beach well catchments. And like any desalination plant this size, it is faced with many challenges every day. Those include, for example, keeping the plant up and running and avoiding unplanned shutdowns, which could lead to more than $2,000 per day of lost production per stop train, with penalties that we might have to pay on top of that. Additionally, when fouling occurs on the plant, it has been estimated that the additional energy consumption per bar of feed pressure increase could cost up to $170,000 per year on OPEC costs. And finally, the plant is faced with high biofoaming risks during summertime, making it really key for the operators to anticipate on membrane performance during that period so that they are able to cope with it without compromising the plant uptime. So let's now watch a video testimony of the plant operating team about smart membranes.
I'm Srinivas Aditya, working as Operations Manager of Sood Desalination Plant, Oman. This plant is a joint venture of Veolia and Bhavan Engineering Company, which produces above 131,000 meter cube of potable water and supply above 350,000 inhabitants in the region. The source of feed water of the plant is from open seawater intake as well as beach wells. The water quality of open intake depends on various factors such as algal blooms and pollution in sea. influence RO membrane performance through biofouling and scaling, and it is difficult to anticipate the state of foiling. The reverse osmosis membrane performance monitoring needs a close follow-up with operational parameters and prediction of corrective maintenance to act in time. A close watch and collection of parameters data are tiresome and time-consuming. Now, thanks to smart membranes, it's transferred to data lake and later to machine learning tool that evaluates the membrane performance and gives us alarms and a predictive maintenance schedule. Smart membranes made life easier for my team and myself. It helped us to save 2 working days, previously dedicated in manual data extraction and analysis, thanks to real-time normalized data. In September 2020, my team able to detect degradation of permeate conductivity. This deviation wouldn't be possible to identify by looking at raw data. The CIP efficiency in smart membranes is an interesting one. It compares the CIP recipes and helps to identify effective maintenance strategy. With this feature, we have adapting the recipe and chemical contact time efficiency of CIP by time.
So now that we have looked at the video, in order to give you a better idea of what the tool provides, I will run you through a very quick demo of the web-based user interface. I will not go into full details for the sake of time, but don't hesitate to contact us if you want a dedicated demo of the tool and to discuss about your plan's specific challenges. Okay, so first of all, the landing page of the tool is the dashboard that recently got a fresh look, as you can see. It helps operators to visualize at a glance if a specific train requires attention. When clicking on history, to the normalized indicators tab, where I can deep dive into the plant normalized data in order to understand better the falling patterns of my system. All the graphs are configurable and all the data can be downloaded in different formats in order to be included, for example, in the reporting of the plant. Then in the CIP efficiency tab, the normalized CIP efficiency of past CIP is showcased. The fact of normalizing the CIP efficiency allows the operating team to compare apples and apples and to easily identify optimization potential. For more I can consult this cycle benchmark tab. I can access indicators like parameter variations since last maintenance, last CIP efficiency, a benchmarking graph and table of the production cycles since the last membrane replacement, taking into account membrane aging. This is the predictive maintenance feature where I visualize the results of the machine learning algorithm and the maintenance recommendations. As mentioned before, the prediction takes into account operators' adjustable settings that can be adjusted for the whole plant or by train. And finally, in the maintenance events tab, all the maintenance events are historized. I can filter through them, as you can see here. And a new event can be added directly from the user interface through this pop-up and will enter in the history and be taken into account by the machine learning algorithms in their training data. So now that we have seen the challenges faced by a large-scale desalination plant like Omansour and what the smart membrane tool can bring to the table to solve them, I propose that we quickly look at a different use case. So smart membranes has been implemented at the end of 2021 on a plant that produces processed water for an industrial application. The plant is composed of 2 duty and 1 standby packaged RO units. The main challenge we face here is different, contrary to Omansour, where a constant team of operators familiar with reverse osmosis is available on site. Here, the RO skids are run by an operating team that doesn't have initial expertise in water treatment. Additionally, the continuity of the processed water production being crucial to the client for the production of the final industrial product, they had to install redundancy, which significantly increased the CapEx cost of the project. This example, we are going to look at an event that happened on the plant in June 2021, so before Smart Membranes implementation, that caused one of the skids to be stopped for several weeks. So what happened is that an operator accidentally disconnected the anti-scalent dosing line, but didn't notice it straight away. We don't know the exact date when this happened, but by looking retroactively at the data analysis provided by Smart Membrane, it is clear that it could have been easy and quick to detect that the unit was becoming heavily scaled, in particular on its second stage, just by looking at the normalized data trend and receiving the predictive maintenance alerts. Since no such monitoring was in place, the unit continued to scale until an automatic shutdown on high differential pressure alarm on the 14th of June. The shutdown was not noticed until a Veolia Water Technologies engineer came to site for a scheduled maintenance visit and discovered the situation. Since no CIP had been planned during this visit, no chemicals were available on site. They had to be ordered, so they delayed the CIP for another 2 weeks, causing a stop of the unit for a total of 2 weeks. So now, if the operator had accessed and used the Smart Membrane recommendations, it could have been possible to get an alert showing that if no action was taken to reduce the scaling trend, a CIP was going to be urgently needed. A site visit could have been planned much sooner to reconnect the anti-scalent dosing line, therefore reducing the risk of membrane damage and saving the cost of one CIP to the client. So as a summary, we could have gone from 2 weeks of downtime and 1 CIP to no system downtime and 0 CIP. And to conclude, just to note that a similar incident reproduced quite recently on the plant, and that thanks to the Smart Membrane module, this time a Veolia Water Technologies engineer was able to come to site to fix the problem, therefore avoiding any shutdown of the unit. So that's it for our second use case. Thank you for your attention, and we will now take your questions.
So yeah, thank you for your attention. You can find more detail about Hubgrade and Smart Membrane on our webpage. You have the link on the slide. So let's move to the question. You can enter your question directly in the webinar. So Marie, first question for you. What sensor data from the plant is necessary to run the tool?
So thank you, Iman. So as I was explaining before, we are using the sensor data of the instruments that are already present on the plant. So to use Smart Membranes, it is not necessary to add additional instrumentation. We just need to connect the plant to collect the data of the existing sensors. So it is sensors like differential pressure, flows, conductivities, etc., etc. So the regular ones that are already used by the operating team to monitor the plant.
Okay, thank you, Marie. Another question: how can we improve recovery?
Okay, so regarding recovery, as of today, Smart Membranes doesn't give a precise recommendation regarding recovery. So the tool is really focused for now on maintenance, so the operator will not get advice on how to adjust recovery. So yeah, we are not focusing on this feature for now, maybe for the future.
Thank you, Marie. Another question. I guess the data is stored in a cloud. So where is it and how safe is it?
Yes, so the data is indeed stored in the cloud. So regarding cyber security, the way it works when we implement Smart Membranes is that for the data going from the site to our cloud, we will discuss with you when implementing, and we will adapt to the cyber security prerequisites that you have that might be different for every site. And then once the data arrives in the cloud, it is fully secured by our cloud partner cybersecurity protocols, which are very strong and certified. If you need more information about this, on our intranet, we have information about all the cybersecurity guidelines that we follow and certifications.
Thank you. Another question for you, Marie. What's the principle of works for this module?
Okay, so I'm not really sure I fully understand the question, so I will try to answer. So the way it works is that it is a decision tool. So it is not a tool that will adjust parameters on the plant. It will give recommendations to the operator to help them make the best decision possible. And it is a data-driven tool, meaning that the recommendations will be based on data that we collect from the plant, that is ingested into machine learning algorithm that learn from the trends and patterns of this specific plant, meaning that the models will adapt to the plants where they are deployed and then provide the recommendations.
Thank you. And how much historical data is needed to train the algorithm?
So in order to train the algorithm, we need enough historical data so that we cover, let's say, the full range of flow regimes that the plant can see, for example. And we also want to gather the seasonality that can be in the data. So I was speaking, for example, about biofouling problems on the onshore plant during summertime. So it will be good if we can see the full seasonality in the data, but it doesn't mean that the tool cannot start working straight away. Depending on the features, we don't need the same amount of data. So regarding indicators, benchmarking indicators, they can start working straight away. The normalization algorithm, we can start implementing it right away. And the training will continue while we gather more historical data, and the training will adjust to the plant. For membrane replacements, that's the one for which we need the most data ready to cover the full range. So this one is the same. It will be able to function, but the predictions will get more and more precise as the tool is able to access more and more data.
Thank you, Marie. Another question for you. The life of membranes depend on which parameters?
Okay, so I would say you can have many parameters that will influence membrane life, but the specific parameters where a smart membrane can help to protect the membrane is really about maintenance. So it's doing your maintenance, and I'm talking about CIPs, at the right time. You don't want to do them too often, because that will be a cost. You will have higher cost for your CIP, but also because CIPs use chemicals, and they might alter and shorten membrane life. But also you don't want to do the CIP too late, because you might have irreversible fouling that will form on the membrane that will get harder and harder to eliminate by a CIP. So that's where the tool can really help to be able to do it at the right time, and also by benchmarking different maintenance strategy, different CIP recipes, chemical concentration, contact time. It can also help to optimize the way we do the CIP. So regarding membrane life, you can have other, let's say, influencing parameters, but they are the ones on which we are focusing.
Okay, Marie. And how is the data link to the cloud design?
I'm not really sure what is meant by a data link. So I don't know, Valentin, if you want to repost something in the chat to get more precise about data link, and we can come back to the question.
Yeah. So go to the next one. Where are the sensors placed inside the membrane?
Okay, so as I was explaining, we are really using the data of the existing sensors on the plant, meaning that we will not be decision makers when implementing smart membranes about where to place the sensors. We will really adapt to specific use cases, to what is present on the plant. So it will be let's say regular sensor positioning, but I can also put a note on the fact that at Veolia Water Technologies we have also developed the smart connectors. You can find information on our intranet about that as well, and it's possible also to use the smart connectors data in smart membranes. And the smart connectors, the particularity is that they measure conductivity data more precisely than we usually do, because they can be placed in between each membranes at the spacer, meaning we will really get a mapping of the whole trains, and that we will be able to detect exactly which element is failing if we detect a problem.
Okay, thank you, Marie. And what about RO normalization and seawater membrane fouling?
Okay, so as I was saying, we provide normalized fouling indicator in the tool, and it is based on a machine learning algorithm. So we don't use the usual equations. We have developed a machine learning algorithm that we have benchmarked against those suppliers' equations to make sure it is performing well. And it is thanks to this normalized data that is made available to the operators in the tool that we are also able to detect fouling in the plant, because as you probably know, the fouling indicators that are usually followed up by operators on the reverse osmosis plants can be influenced by external parameters like temperature, if I take the example of conductivity, meaning that sometimes you will have an external parameter that will cause a trend on your indicator that will be only linked to this external factor, and that can hide a real trend of fouling. So the idea is really to normalize the data, remove the influence of the external parameters to just visualize the evolution of the fouling on the system.
Thank you, Marie. And how applicable is smart membrane outside of seawater desalination?
Smart membranes is applicable to other reverse osmosis systems, even if they are not using seawater. So it can be also brackish water, surface water. Actually, the second use case we talked about, processed water production, is from surface water. It's not seawater desalination. Sorry.
Okay, and how the smart membrane will reduce the fouling?
So as I was explaining, the tool really focuses on optimizing the maintenance strategy of the plant. So it will not actually reduce the fact that fouling appears on the membranes, because we cannot avoid that, but it will help operators ensure that they deal with it the best way possible.
Okay, and Valentin shared with us a question. How is the data protected when it gets from system to the cloud? Okay.
So I have to admit that this question is a bit too precise for me, because I am not a cybersecurity expert. So I suggest, Valentin, that you contact us separately, and I can put you in touch with our cybersecurity expert that will explain that, because it's really not my area of expertise. I'm sorry.
Okay, let's take another question. Does this module installed on each membrane vessel or on for the plant?
Okay, so the module, we can adapt it, as I was saying, to also the instrumentation that is present on the plant. So it will really be the choice to make when we install the module. Usually we follow train by train. And if the necessary instrumentation is present, we can also follow stage by stage or pass by pass if it is a plant with several stages and passes. So we really are able to adapt. The tool is modular. And if the smart connectors are installed on the plant, we can even go, as I was saying, to the step of the element itself. So it really depends on what instrumentation we have. And of course, let's say we implement smart membrane on a plant where we don't have interstage instrumentation, we could also consider installing instrumentation for the sake of being able to run the tool at this granularity. But it's really modular.
Okay, thank you. And the last question that we have time to talk. If the system is predictive, then why not have a standard maintenance routine based on the data?
I guess that by standard maintenance routine, it is meant that to have kind of a fixed schedule. So the idea is really to have a tool that is there to act in time, because you have regular trends of fouling, biofouling that happens in summer, that comes back all the time, etc. But you can also have, let's say, unforeseen problems on the plant that might happen, and the tool will also help to detect those problems. So that is really to have the tool that always monitors the data. The machine learning algorithms, we don't train them just once and then they are fixed. They keep learning from the new data. So the recommendations will adapt if something evolves on the plant. So if the plant is really stable and the data doesn't evolve so much, we will end up with kind of a standard maintenance routine because the recommendations will be quite regular. But the tool keeps monitoring in case something happens and we need to intervene. And in terms, let's say, of maintenance strategies, so I would say maybe etc. As I was saying, the idea is that by using the tool, we are able to benchmark different strategies and then ultimately choose the right one.
Okay, thank you so much for your attention, and sorry for the question we didn't have time to answer. So don't hesitate to contact us directly, and the contact email will be addressed to you in the other email. Thank you, Marie.
Thank you, Iman. Thank you.